Here we're going to look at one more example of two equations, two unknowns, and pick a method to solve those. So our third example is x plus 2y equals 4 and 7x plus 14y is equal to 28. Okay, now it's totally your decision whether you like to use substitution or elimination. Most people prefer elimination. I definitely prefer elimination. The main reason being sometimes there is not one variable that is easy to solve for. So, this x makes substitution fine too. This first x that has a coefficient of 1. But a lot of times this number might, or this variable might have a coefficient other than 1 as well. And then you're getting fractions and it could just be really messy. So elimination prevents all of that. So for this one, let's say we're going to use elimination again. Okay, and it looks like we could multiply our first equation. We would need to multiply that by -7, correct? In order to add the two x's together and get -7 plus x plus 7x get 0. Okay, so our first equation becomes -7x minus 14y is equal to -28, okay? And then you might have noticed, oh, in the second equation that this is 7x plus 14y, these are both going to eliminate, and this side is 28. So this time, when we add our equations together, we get 0 on the left and 0 on the right. Okay, now that's pretty useless in a way. It does not tell us what x and y are, but it does tell us that that's true. Okay, and so what we have is two lines that are actually the same line. Okay, so same line, whoop, and that would be infinite solutions. Okay, and so what we can do is for our solution, we say what x is equal to, and then we can say that y is any number. So the way to answer this, you can solve for either one of the variables. You can solve for x or y. Okay, it is the same line. It's easiest to solve for this x in the first equation. So that would be x is equal to -2y plus 4, right? Subtract the 2y over. So x is equal to 2y plus 4, and then y is all real numbers. Okay, we can put any number in for y, and that will give us what x will be, and we can do that for any number, and these equations will be that same line. So that's just defining the line there. So I want to show you a picture of what we've been talking about when we have different types of solutions. And so I definitely want you to draw this and write it down. So let me see if I can just look at this a little bigger. There we go. Okay, so we've had two lines. The first example that we did was one line and another line, and they intersected in a point, x comma y, okay? And when you have intersecting lines, the system has one solution. You find that solution, and that is called a consistent, independent set of equations. Okay, they're consistent because there's a solution, and they're independent because the two lines are different lines, they're just crossing in one point. Okay, so consistent and independent. And then the second example that we did, there was no solution, right? And that is always going to look like parallel lines. Okay, and the system will have no solution. So your answer is no solution. That's called an inconsistent solution because it has no solution. And then finally, the third example that we looked at, they were the same line. Okay, we got a true solution, but we couldn't find x and y because X and Y are all the points along the entire line. So coincident means same, and the system has infinitely many solutions, and we saw how to write that. And it's called consistent because it does have solutions, and it's dependent because the lines are the same line. So make sure that you write down this picture because you are in your homework, you're asked about what these solutions mean and the vocabulary there.